So welcome to Gardening for Dummies. Today we're going to talk about a deep technical dive into how to... Okay, no, so the topic today is... There we go. All right, but before I get into this, so let me introduce myself, and it's a pleasure to be here, so thank you very much. My name is Scott Klein, as Mike said. I'm a technical evangelist out of Redmond. I just happened to be here because I was at Tech Days last week, and then doing a train-the-trainer. So I've got a few more days, and I finally get to go home. Before I get started into this, so my responsibility in Redmond is I am the corporate technical evangelist for all of the Azure data services. So, and I apologize in advance, I'm going to call this SQL Azure just because it's been SQL Azure forever, but if I say that, I mean SQL Database, okay? So, but I'm a technical evangelist for all Windows Azure SQL Database services. So that, Federation, migration, reporting, data sync, all those services, including Azure Storage, tables and blobs, and then SQL in a VM, okay? And any other new service that is data related. So, how many of you are the SQL people? Don't be shy. Yeah, it's okay. Yeah, sorry. Yeah, I contracted it last week. I'm still trying to see the doctor about it. There's a few more weeks, I'll be over my SQL illness. That's right. Start getting rid of it. Get it off. So I'm assuming that most of you are .NET developers or developers, right? So how many of you have experience? I'm assuming because you're here at this at this user group that you're all familiar with Windows Azure, right? Yeah. Okay. This is not a comedy act. Well, boy, my arm's tired. No, I'm kidding. So, from a developer perspective, right? What really matters to you? So I want a two-way conversation here. I don't want to do all the talking. What matters to you from a developer perspective? When you're developing applications for the Azure platform, from a developer perspective, not from a data guy, because that's a disease. We don't want that apparently. What matters to you? What are you concerned about as you're developing applications for Azure? Come on, throw them out there. What matters? I mean, what's a concern? What do you really, is it? I know performance is always an issue. We can talk about that all day long. But what really concerns you?
Security.
To the data, correct?
Yeah.
Okay. What about security? I mean, I want to get as deep as possible. Is it that just people can come get my data? Is it how do I access it? Is it?
Yeah, transfer security, data security within the data center.
Okay. Is that anything else? And we can talk about that, right? What else? And the reason I ask is because I've got this presentation because I'm a data guy, right? I'm SQL Server MVP. I was one of the first 4 SQL Azure MVPs. So I deal with data. I could probably do .NET, but you guys can probably do application development much better and faster than I can, right? So I have this concept of I have this concept that what I think should be talked about, but I want to hear from the developers what security, yeah, so we can talk security and I can talk about that, but from a developer mindset, what's a concern? That's security. What's that?
Reliability.
In terms of uptime?
For example, or having your data replicated, putting applications online, not having to worry about instances going down or servers going down or DNS or whatever.
From the data side, right?
Or from the application side, for example.
Okay. All right. So yeah, we can talk applications, but I'm more concerned about the data side. That's fine. Do you have an application concern? Yeah, that's fine. Yes.
Ease of access for developers to the data.
I'm sorry?
Ease of access to the data.
So
APIs are not extremely complicated. Decent or
you're talking the Windows Azure Management API or SQL Database Management APIs?
Look at the past. We had ADO.NET, Link to SQL, Entity Framework.
You want more or less?
Less, please.
I don't think that's going to happen. Yeah, so I don't think that's going to happen only because there's a lot of languages out there. I mean, Azure supports PHP, PHP, Java, Node, .NET, all the tools. And we can't. And if you're going to see, we'll probably see more, not less, only because there's other languages out there that will eventually want people to migrate onto Azure. So not that we're trying to make it difficult, but I'm sure there's people that want to use that want the benefits of the Azure platform, but.
If you look at ODBC, that was more or less percentage.
True.
Yeah, the performance was like crap.
So, but we actually do support ODBC. Are you saying you don't want us supporting ODBC? I don't know. Right. Yeah, I mean, I understand what you're saying. Right. What else? Like scalability, or you care from an application standpoint? You care about database scalability? You care about other than security? What do you care about? Or and I don't mean this in a negative way. You care about, as an application developer, do you not care about the database? Do you not care about the data? Other than maybe a few major things like security, do you not? Do you have more? Not you specifically, but do application developers? Yeah. Yeah, do application developers? Yes, right. All right, stand up, you up. That's right. We found the one guy. Do application developers in general not care about the data? Or
As long as it's there.
Yeah. As long as I can query it, I'm okay.
Imagine a way as you do it on code first on entity framework. Imagine the same way that I can store data in a relational model using entity framework, but I just don't care where it goes and how it gets persisted. I just want it to be there and be performed. Right?
So as developers, you're just saying, I've got this data, and as long as I can code against it, I'm okay?
Yeah, and in a way that it's performant. Like now I'm running that query and it takes, 2 minutes or 5 minutes to run, just a random example. How can I make it run in less than a minute? Imagine a way that as I increase resources on a deployment, I say go from small to medium, I increase throughput for a query, so to speak. I get more resources to do stuff, to make a query run faster. Could be that I do optimizations as well, yes. But as I say, I don't deal with optimizations because I deal with the abstraction of the code first thingy.
Yeah, because all from an application development, all you care about is it's taking too long for my data to come back.
Yes.
Is that your statement?
Could be.
And at that point, you go talk to the SQL people and go, why is this taking so long to come back? Right? Okay. Which is it's sort of fixable, right? Because when I say sort of, meaning, so you could still tune your database. So a lot of things that apply on-premise now, as far as query tuning, still applies in Windows Azure SQL Database, right? I can still open SQL Server Management Studio, run execution plans, query plans, and tune but until we get in Windows Azure SQL Database, until we get the ability to guarantee and reserve resources, just like you can on websites and virtual machines and things like that, your performance in Windows Azure SQL Database will always vary.
But not only that, imagine the fact that we use SQL federations, and I want to say, so in the back, it does SQL federations on its own. I tell you that I want to use that key, blah, blah, blah. It does SQL federation on its own. Then I realize that it is going slow, and I request more performance. I want the system to know that it could possibly split the entities even more, creating a different SQL federation key to increase performance, right? I would like that stuff coming from the platform, not me.
So it comes from okay. So you can, how do I say
Probably
it?
Klein will kill me saying that.
What's that?
The vehicle will kill me saying that.
Not anymore.
Not anymore.
No. He's actually on a different team, and I think he's actually leaving Microsoft. So in terms of that, the issue we have with that is, from a performance standpoint, in application or database, it doesn't matter. My definition of load and performance degradation and things like that, it can and probably will be different from your definition of a load, right? And even even if we were to automate that, There's a challenge with that because how do we determine load?
I tell you that I want to scale.
Okay, so you can tell us,
Yeah.
you can do that now,
Yeah.
right? But we're not going to automatically go, hey, we're not going to automatically go, hey, you need to partition, right?
And I will like that.
No, and we're probably not going to do that. And why?
Costs.
Say that louder.
Costs.
Cost.
Same as
Right.
scaling automatically.
Right, yeah, it's the same way as, so when you
Yeah.
provision a database, you provision a 40 gig database, or whatever size database, when your data hits that limit, what happens to your database?
Expands, gets bigger.
On premise.
Oh, premise, okay.
What happens in the cloud? Sorta. Right, sorta. Yeah. Well, so no, if you hit that, like if I provision 40 gig database, and somebody decides to load 40 gig worth of data, and I hit that limit, our database goes into read-only mode, right? It doesn't auto-increase, and the reason we do that is because of price. You paid for 40 gig, all of a sudden you're getting billed for 50, make sure you get their good side. We don't want phone calls from because you got 45 worth, of data or whatever, right? We don't want those. We won't want those calls. That's
Yeah,
why.
but I still tell you, the platform, increase my performance by increasing that. I know what that is, and I'm requesting for that to happen, right?
Right, and so
Don't do it automatically. I just know that something goes wrong, and I want to increase that performance because I know that something is not going well there.
Yeah.
I want you to do it for me. I don't want me to find, let's say, the specific partition key or a way that I will have to choose what range the partition keys need and whatever. You already have the data, what kind of data is being accessed by me, what index gets accessed by me. The partition key is there. You can, for example, give me some suggestions that you might want to change this from that partition key from that range to that range, because that way you're
So
getting more performance and stuff like that.
So we may get there at some point.
Multiply the index.
But and there's tools out there right now. I mean, there's a bunch of DMVs, data management views out there that will tell you what's my load, why is it query, what's going on with the query, things like that. At some point, we may get to the point where, because right now you can actually build something that says, based on this criteria, from what I'm reading from these DMVs, I either need to scale or things like that. We can't tell you what key to partition on. We don't know your data. We don't know your database. We can't tell you that, and we'll never ever tell you that. But we can tell you, hey, this one, right from we'll get into SQL Federation, right, in detail if you guys want, right. But what we're doing is we're saying, when you partition your data out, you've got X amount of partitions, and you want each partition. You want the load on each partition being the same, right? You want that distributed evenly, right? And if one is getting more busy than all the others, and it's continually more busy than all the others, then you can say yes, now we're going to partition that out. And what's the cause of that, right? Is it one guy that's just being an idiot and and foobarring the system? And you guys know what foobar is, right?
Yes.
Okay, all right. Huh?
I work with Robin, so I know.
Someone just got thrown under the bus. Right, but so at that point, right, you can take that one guy out or partition or things like that, but we're not going to pick those keys for you. So
Don't pick the keys for me. Just let me know.
so we
Suggest
can.
me. No, don't suggest me a key. Suggest a different range in case a partition is getting hot too much for a very long time.
Okay.
Just like the index tuning.
Yeah, but you can look at.
Almost like an index tuning.
Okay, you can sort of do that now, but that's okay. That's good. Okay, so in here we're going to talk about the things that after talking with people, thought that developers would want to hear and talk about. If that is not the case, right, we'll talk about security, right? We'll talk about things like that. Because security is always an issue. That's always number one, right? We'll talk about some of the performance. But if there's things that you go like, you know what, it'd be nice if we did this, let me know. Because this is kind of based on so there is my Twitter, my email address. If you guys ever have questions, I'm happy to do whatever, right? Email. There's my blog. There is a L. I think it's the font. There's an L between my first name and the last name. You can't really see that well. And then we're probably going to change the day, but we have this thing called, me and another guy have this thing called Windows Azure Q&A Live. And what we do is, I think we're going to charge it, because right now we have it in Belgium time. It's Friday at 6 p.m., which we would never get anybody in Belgium on the call, apparently at that time. So we're going to accommodate, I think, more of the European side and not get everybody at lunch, right? We're going to probably move it to what would end up to be Thursday about 5 p.m., right? I don't know if that's still going to interrupt, but we're going to try to find a day. Anyway, what Windows Azure Q&A Live is it a live, basically, chat, where if you go up to that URL, every week we have a special guest that's from the Windows Azure team, right? And that could be from mobile services, could be from the data, it could be from websites, it could be from storage team. And what we do is you can go up there, you can pre-ask or enter questions, and then on the day of the call, we have the special guest in, and me and the special guest and this other guy, we basically just have an open chat about the questions that have been asked, and allow you to come in and ask questions about anything Azure, right? So we don't block it. It is an open forum. So it doesn't matter who you are or where you're coming from. It allows you to ask questions about Azure, whatever it is. Okay? So that's the bankochips.com/office hours. All right. So with that, let's move on. Okay. So like I said, these are the topics. I don't know. Can you guys see that clearly? Okay. To me, this was and security's not in there, but we'll talk about security. Because, and we'll actually talk about that after we talk about architecture. But these are the things that if I was a developer, I'd want to know about the data services back there, right? So primarily there's two main ones that we as developers work, or that you as developers that I've got to work with, right? The database, obviously, right? And then from the Azure storage, we have the Azure tables, right? Is that a safe assumption? Yeah? Anybody disagree with that? No? Okay. And then we'll talk costs and things like that. Okay. So, architecture. Let's talk architecture. So this is PaaS. We're talking about everything's PaaS platform. Okay, so here's how it works. You guys familiar with the architecture of Windows Azure SQL Database? Anybody familiar with this? Right? It's really not that different from Windows from SQL Server. So this goes, and I think this guy in the back's not going to want to hear it. Yeah, go ahead.
Can you zoom in a little bit?
I can. Let's see. Let's do this. I don't know if I can zoom in while it's running. Well, actually, you can. Okay. Does that help? It looks good on my machine. All right.
You sound like a developer.
Yeah. It works on my machine. All right. Let's do that. It's zoomed in here. Okay. That better? Okay. All right. Yeah. Okay. So contrary to what this guy in the back wants to hear about everything that works with Azure, right? So there's the client layer, which basically says all the technologies that you know and love and use today still work with Azure, right? And as more come along, we'll probably support those as well, right? Because it is, guys, you know this. Windows Azure SQL Database is SQL Server, served up as a service, right? But there are some differences, right? But it is still SQL Server. So tables, views, store procedures, triggers, all the great stuff about it, right? This is nothing new. Still talks TDS, ADO.NET, still talks TDS, but all the protocols, ADO.NET, ODBC, things like that, that still works, okay? The difference is, in this architecture, is this middle services layer, okay? This services layer is responsible for provisioning, connection, billing and metering, and connection routing, right? Billing and metering, it basically says this layer tracks how many databases you have, when they were created, how long they've been up, things like that, size, all that great stuff, right? Provisioning, this is responsible for saying when you provision a database, it goes out and into the entire data warehouse and says which 3 servers in this entire data warehouse are the least busy that I can create your primary and 2 replicas on, right? That's its job, and then it does that. Now those databases probably will never ever stay on that same server, because Azure, as we'll see down below, actually right there, the Fabric's job is to make, on every physical SQL server back there, its Fabric's job is to make sure that your servers, your data servers, or your SQL servers, your databases on those servers always get the best performance. So it may be created on one server one day, but next week it may be on another server because Azure determined that we're going to get better performance by moving that database, right? But we don't care. As developers and as SQL people, we don't care. We just want performance. So we don't care where it's at. And the great thing is you don't have to move it, and you don't have to find out where it's at, okay? So that's provisioning. Then connection routing, its job is you come out, you know the SQL servers or the SQL database server name. It's just a TDS endpoint, and it goes when you connect, it goes where to route your, okay? Other than that, the architecture stack is really no different. You've got your client layer, your services layer, then you have the physical box on the back end running SQL Server. The only difference is that it's running the special SQL Azure agent, Fabric, or Fabric agent, that's basically monitoring the overall health of your SQL Server box, or of that SQL Server box. It's not yours, SQL Server box, right? This is important to know because its job is to make sure that we all play nice in the same sandbox, right? And this is where you as developers are, in my opinion, should be concerned, right? I don't want, like we talked about, when I write a query, execute a query, I want to make sure that I get that data back fairly quick, right? So I don't want you robbing critical resources from me, and I don't want, and I know you don't want me robbing critical resources from you. True statements, right? So how do we guarantee that? And right now we cannot guarantee that, but the agents or the Fabric's job is to do as best as it can to make sure that we get that, right? Now, about at least as early as last June at TechEd, they announced what's called resource reservation. So you know, in websites and in virtual machines, when you create a virtual machine or a website, and even a cloud service, you can pick a t-shirt size. Give me dedicated resources, correct? Right? Wouldn't it be nice to do that from the database side? Yeah, the answer to that is yeah. Yeah, right? So in SQL, pretty soon you'll be able to pick and say, I want dedicated resources. To guarantee that when you execute a query today, that same query will execute with, the same way next week. So we can guarantee resources. So you'll be able to say, hey, when I create a database, I want this database running on a extra large instance. So give me X amount of CPU, guaranteed, reserved CPU and memory, right? So that's going to help. Right now, but just like everything else, you can still use shared resources if you want, right? But right now, that's what we have. All right, and then you have the infrastructure. So that's the architecture, and that's probably not anything new, but that kind of helps to understand, what's available today and how do we use this and what do we do from an application to basically write better performance. But let's talk. Let's talk security. Okay. Let's fire that sucker up. Perfect. Okay. Security is always an issue. We get that every single time, right? And especially here in the European Union, people are like, I don't want my data leaving the data center. I don't want them leaving the borders of my country. Even in the United States, we have things like HIPAA and whatever. All these anal. It's frustrating, right? So you guys know that when I provision a server, I don't even get access to that until we configure firewall rules, right? How many levels of firewall rules are there? Huh? Two. What are they?
Server and database.
Server and database. And the database firewall rules are actually fairly recent. They were added like late last year, right?
September.
Huh?
September.
Yeah, September. I think October. Yeah, around there, right? You can provision the firewall rules on the server through the portal, but if you want to do that at the database level, you got to do it through T-SQL, right? And that's not anything different, big deal, right? However, that means, but what does that mean from a security perspective? All right, why, as a developer, or even as from your customer perspective, why do we care? Why is that important?
Security granularity.
Yeah, security granularity. So the fact that I can provision a server and I don't even get access to it from, the only way I can get access to it is through the portal. But the fact that that's the only way I can get access to that should mean something to me, right? So how's someone going to crack open, how's someone going to get access to your data, right? One of the big things we get all the time is, why is encryption, how many people get asked that? Why is encryption, and how many times have you asked that? Why is encryption not supported? How many people have asked that? Come on. Right? No one's asked that? Really? That's a first. Okay. Well, the reason encryption isn't supported, anybody want to take a guess? I didn't want to shock and awe. I mean, they're like, what? It's not? Why isn't encryption supported? And let me just throw this out there. Why won't it be, at least in the near future, why won't it be supported? What is encryption based on? You know, because we had this conversation the day before anyway. Certificates, right? Certificates are server-based, okay? Which means that if I have a certain level of encryption, I may use SHA-1, and you have a different level of encryption, you may use DEC or whatever, right? How do we solve that in a shared environment scenario, right? So that makes it difficult, so we're probably not going to support encryption. However, another reason they're probably not going to support encryption is because how on earth are people going to get access to your data anyway? What pieces of information does a hacker need to get access to your data? What do they need? Come on, name them off. What do they need?
Social skills.
Social security, what? Social security number?
Social skills, social engineering. So they can get your username, the password.
Well, even at that, right? They need the username, password, server name, and what else?
Firewall.
The firewall rule. So the only way someone's going to, so there's two ways people, on premise, there's two ways people get access to your data. One is someone actually walking up, grabbing the box, taking the drive out, and leaving, right? Number one. Okay? Number two is by hacking in, right? Number two. Well, in order for someone to hack in, they need 4 pieces of information, right? What are the likelihood, and for them to get the 4th piece of information, which is the firewall rule, you have to give them that access to that piece of information. You specifically have to say, I am granting you access to this server, right? So unless they have that, they could have all 3 other pieces of information: username, password, server name. They can have that. You can give that to them all day long, and unless you give them and specify the firewall rule, they will never get in. So the likelihood of someone stealing your data is slim to none, or spoofing in, right, or hacking in, okay? And the other issue, someone actually walking up and stealing your drive. Has anybody tried to break into Fortnite or whatever? Has anybody seen one of the data that you have? One of our Azure data centers? What's it like? Yes, it is different. How many employees work at, Microsoft employees work at a data center, Azure data center? Huh?
None, actually.
One.
Okay.
One guy.
Who?
Huh? At most, one guy. Right? Because for the most part, there's sometimes there's one guy.
Okay, sometimes. Okay.
Sometimes. That's why I said at most.
Yeah, usually they say none. That's why.
Well, they say none, but someone's got to go in there and sweep the floor and
He's
change
a Microsoft employee, not a
and someone's got to go change the toilet paper.
Contractors can do that.
Yes, you didn't record that, did you? All right, but someone's got to manage and make sure the maintenance of the hardware and things like that, right? So sometimes one, but most times 0, right? When you provision a database, even we don't know where it's at. We don't know what container, what rack, and what spindle that database is on. We don't know, right? So from a security perspective, nobody's getting in. Nobody's getting your data, probably ever. The only chance of that is if, for whatever reason, and people freak out about this, but I think in all the many years of having a data center up or whatever, it's having the government come and going, okay, we need this for a high security reason, right? Someone's right, but the chances that, excuse me, chances that are, I think, very slim to none anyway, right? So it's just security is not an issue as far as I'm concerned, right? Does that make sense? And please tell me if you disagree. I mean, are you okay with that, or you guys disagree, agree? What are your thoughts on that?
We don't, our customers do.
Well, okay, you're speaking for your customer, right? But I mean, is that something you can go back to them and say, hey, look, right? So anyway, that's food for thought. Okay. Application connectivity. Okay. So as a developer, these are kind of the top 10 or 9 reasons, or kind of things that, as if I'm developing an application, and if there's some, let me know if there's some that should be on there. If there's more that I'm missing, let me know, right? But these are the kind of things, like, see, number 1's not even, that's just kind of an FYI. I don't even know what's on the list, right? But these are kind of things that as a developer, there's about 6, 1, 2, 3, 4, 5, 6, about 6 of those 8 or 9 things that I, as a developer, and please again, tell me if I'm smoking something and I'm completely wrong, to be concerned about. For example, let's just walk down the list. Idle connections, right? How long does Microsoft wait? How long does Azure wait before we terminate an idle connection?
59 seconds.
Oh, that's that's harsh. No, 30 minutes. So after 30 minutes, we have basically a garbage collection process that goes through occasionally. It's not every 30 minutes. I think it's about every 5 minutes, right? But every 5 minutes, we have a garbage collection process that goes through and finds that any connection to a SQL database that's been idle for 30 minutes, we terminate, right? Because as a developer, that's important to me, right? So let me know if it's not, right? But number 1, long-running transactions, right? This is and all of these kind of lead up to numbers 7 and 8. 6 and 7, okay? Long-running transactions. So, same thing, the process will go through, and if there's a long-running transaction that's been running for more than 24 hours, right? And please nobody raise their hand and tell me that they've had a process running for 24 hours. No, I don't care if it's true or not, don't admit it, right? But it'll go through. If there's a process that's been running for more than 24 hours, Azure will kill that process. Okay, just done. Because again, this is the, hey, we want everybody playing nice and not robbing resources from other people, okay? Number 2. Denial of service guard. What is the 2 things on the end of a connection string that we add that's not, you typically don't see on an on-premise connection to help with, or let me just stop there. What are the 2, I guess we'll call them parameters, I'm drawing up parameters that we include on the end of a connection string for Windows Azure SQL Database that you typically don't see on an on-premise connection?
Trusted connection?
Yeah, isn't that, you typically don't see that on a, do you?
So, application.
Huh?
Application.
No, it's trusted connection equals false and encrypt equals true. Right, those are the 2 things. And what those do is when we come in with that, that's kind of our way of looking at the connection and going, okay, and kind of we're always monitoring for denial of service, right? And in fact, where were we? Shoot. We were at a camp just a couple weeks ago. Where was I? Have I been on the road that long? We were actually at a, I think. Oh yeah. Okay, so we did it. There was a
Belgian beer.
Yeah. What was that?
Belgian beer.
Yeah. Belgian, that hot chocolate really is. All right, we were at a.
And the false.
And cut. All right, so we were at a conference in Montreal, Canada, and we were doing a kind of a hackathon. So we had all these people that kind of doing the same thing we were doing, like a train the trainer type, but it was a hackathon. And we had people come in and say, all right, everybody sign up for an account and start working, right? After about 30 minutes into the hackathon, everybody got an email saying your account has been closed, right? Why?
So many connections from the same IP address.
Yeah, we were all coming through the same essentially through the same IP address. Microsoft said, "Holy cow, we're being hacked," right? And basically shut everybody down, right? So we're serious about it, but sometimes we take it a little too seriously, I think, right? But so we're for us as an application developer, this is kind of things that this is just more of a things to keep in mind. How do we architect this so we don't run into situations like that, right? So more of a, do I do, because I think it goes back to when I provision a set of firewall rules, is it a single one or am I specifying a range? How are they coming in? How are they connecting? Kind of leads to number 7 as well, right? It's the denial of service guard. Okay. Throttling. This, I think number 7 and 8 are, I think, the two most, 6 and 7 are the two most things from an application as a developer standpoint that you need to consider when developing applications, right? But let me start with number 7 first, right? Connection pooling. How many people actually use connection pooling in their applications when connecting to SQL Server? A couple of you. Okay, I'm gonna ask pointed questions. I want to get there. Why are there other? I don't mean this to sound rude, so please don't take it that way. But why aren't other people adding connection pooling in their application? What's probably the reason they're not doing connection pooling? Idiots. Huh? Idiots? I think he just called some of you idiots.
No, I didn't.
Right. So I think. SQL Azure, I think in a lot of ways, I've said this for a long time, SQL Azure forces you to do things the right way, okay? So if you can, use connection pooling, because that helps eliminate number 2, especially number 2, right? Idle connections, right? That leads to retry logic. As developers, how many of you tried to build in retry logic into your applications? One, couple of you. How easy was it? Be honest.
Huh? Balls.
Huh? How easy was it? Was it easy or was it really hard? Come on, be honest. Was it difficult?
Yes.
Yeah? Right? It is difficult, right? It's not that easy to build retry logic in. However, what this does, it allows you to do things like number 6, which is track for throttling. But retry logic, did you guys know that there's automatic retry built into the .NET framework? You guys know that? Okay. Let me fire something up. Oh, let me get through number 6 first. Okay. I should say sort of built in, but I'll get this. Throttling. Retry logic, I would highly recommend it's from an application, because if you're connecting on-prem, you're not going across the wire, you're not going across the network, or you may be going across the network, maybe VPNing in, but you're really not going that far. Your latency isn't that much to connect to your on-premise SQL Server, right? But if you're going kind of to the cloud, to the data center, there's a lot of things that you have to be concerned about, latency, things like that, right? So from a throttling perspective and retry logic, I would please use retry logic, and it's not that hard. And the reason we get into throttling is because, remember that agent we talked about that sits on every SQL Azure box that's kind of making sure everybody plays nice, right? His job is to let Windows Azure know that this guy's not playing nice, and Windows Azure may at some point throttle you. Who's heard of the SQL Azure throttling before? A couple of you, okay. Throttling. We may, at some point, if you're foobarring SQL Azure, we may throttle you. And there's hard throttling and there's soft throttling, right? And this is why I get into retry logic and things like that. Because you want to trap for these kind of errors. When we throttle you, soft throttling really sort of means we may scale you back just a little bit. We may we may sort of take some of the resources. We prevent you from doing something. I mean, soft throttling means you're not doing something too bad, but there's a potential that you could be doing something bad because you've been doing something for a long period of time, right? So soft throttling are things like we may limit the number of connections you can make. We may limit the amount of resources you can use, things like that, right? That's sort of soft throttling. Hard throttling, if you get hard throttled, just pray you don't get hard throttled, because that could be something like, we're just going to refuse all connections from you for 30 seconds or a minute, and we may kill every single connection you currently have, right? We may do that, right? And you really got to be doing something ridiculous and stupid to be able to get to hard throttling. But we may do that, right? So if you're just, you probably won't see this kind of level of throttling if you're doing, once resource reservation gets there, because hey, if you want to take your own resources, have at it, right? But if you're in a shared environment, we'll implement throttling, right? And so hard throttling can be quite severe to, yeah, we're just going to kill all your connections and prevent you from connecting for another 30 seconds to a minute to even longer if you're not playing nice, right? The key then is, how do you track for that? How do you know you're getting throttled, and how do you know why you're getting throttled, right? That's the key. Okay, so.
But it's kind of rare to get throttled in these days. I mean, you really have to try to get throttled in SQL Azure these days. In the past, it was a bit easier.
Yeah, so we're saying that in these days it's kind of rare to get throttled, and that's true.
Yes. It's quite rare too.
Huh?
It's quite rare. You really have to do to get hard throttles. I've tried like a lot of stupid stuff and I didn't get throttled.
I've tried stupid stuff and I'm not getting throttled yet.
I have to know when. So.
Well, no, agreed. So more than likely these days you'll probably get soft throttle more than anything. Yeah. But I bring this up because there is hard throttling and you got to prepare for that, right? And the reason for this throttling is, if you look at the nodes in SQL Azure or SQL Server Management Studio, right? There in 2008, I think, started with the resource governor. And the resource governor, you can go through and say define process and how much resources are defined to a specific process and things like that, right? So what we did is we don't give you that ability in SQL Azure, because we say we kind of tweaked that to say how much resources do we want to give you and things like that, right? So in the early days of SQL Azure, we basically we're messing with how much resources and things like that, how much do we give you, and you saw a lot of soft throttling and you saw more hard throttling than you should have. We're still tweaking that. It's getting much better. But there's still, there's still people going, hey, my query's not taking this, my query's taking too long, or I'm running this big thing, and it's still going on after 18 hours, and right, there's still some tweaking going on, but at the same time, you still as a developer need to be prepared to go, if there's an error, what happened, and why did it happen, right? Number one. Okay, so, but you're right, being hard throttled is rare. Okay, so with that, let me jump out really quick. And what I'm going to do is I'm going to open this flow. I'm going to open this. So I've got a very simple demo app, right, that shows. Where's it at? All right, so I want to show you a couple things. Demoing this is kind of hard because I can't duplicate being hard throttled or soft throttled. But what I can show you is how to track that. Right. So adding retry logic into your application is as simple as opening and going to not references, but going to the, your solution, doing a NuGet package, and searching for, manage NuGet packages, and then searching for the transient. Should come up here. Come on. Yeah, enterprise library. This one, enterprise library transient. It's called the. You can see that. The transient fault handling application block. This is part of the enterprise library. So just you click on that, click install, and it installs all the appropriate components you need. It's got a green check mark because I've already installed it in this, but it installs all these necessary components to build in retry logic. All the enterprise components, right? So I've got just a couple of quick examples, simple examples here. All right, so this is number one. I'm just doing a standard you guys can see that. Right? This is using bar connections. This is kind of a simple example. Let me do this. Let me jump out there. There. See that better. Right? It's just called the reliable SQL connection. Right? But in this case, I haven't done anything with it. I'm just saying use the reliable SQL connection. This really doesn't do anything. Right? But what I can do, and really the strength from this, comes in the fact that down here, oh, other way. Ooh, no, didn't want that. Okay. So can you guys see that? So what I'm doing, looks good on my box. All right, there we go. So retry policy. So with the transient fault handling application block, that is so hard to say fast a couple times. But it's basically you're defining a retry policy, and in that retry policy, you're saying how many times do I retry, and what's the length of time between retries. Okay. So in this case, I'm just defining a policy that says try me 3 times. At the very end, I think I'm saying wait 10 seconds. Yeah, wait 10 seconds between retries. Okay, and then I just the reliable SQL connection, and this is just a wrapper around the standard SQL connection class. That's all we're doing, right? So reliable SQL connection, and we're passing the connection string and the policy. And by applying the policy at the SQL connection, that will automatically filter down to the command object automatically, right? So now if I want to, there's also I think I showed you this, there's also a reliable SQL command class that if we want to apply a different policy to, we can do that, right? So it's down. There we go. So we're doing the same policy, but we're but we're also applying it here. We're just instead of applying it at the SQL connection, we're applying it at the command. Now, one of the things. Oh, no, you know what we're doing here? We don't do that here. Sorry. Did you know that, the reason I brought this up is because did you know that the standard SQL connection, and I think I asked this earlier, standard SQL connection class comes with retry built in? Right? It's right there. So you still have to define the policy, but open with retry has been around for years. Right? How many people knew that? A lot of us just use .open and go, right? Right? And then pray nothing happens. But open with retry is standard SQL connection stuff. Open with retry and open retry with reader, open execute reader with retry. Right? Same thing. That's been there for I don't know how long. Right? But most people don't know that. Now you still need the transient fault handling application block to define your policy so you can apply it here. But the challenge then is if you want to define the policy and you want to use the reliable SQL connection, how many people are open to modifying your data layer code? Granted, it's probably not going to be a lot unless that stuff's spread out all over your application, right? But if it's not, just do add the transfer application block, define a policy, and then just use, instead of open with retry. So your changes to your application are much less, right? So you've got several options there, but at least you have retry. Okay, how many people use Entity Framework? Woo, good, a lot of you. Did you know that you could use the retry policy with the Entity Framework? Right, same thing. You can actually use retry policies with your Entity Framework stuff. Awesome! Right? I don't know. I love that. Okay, so the reason I bring this up, and I don't have a example, but what I'm going to do is I'm going to later on. There's a blog. I've got a blog article, and there's stuff on MXDN, and I meant to put it in here, and I apologize I don't have that. But what I'll do is I'll show it to you. Is that the reason you want to use this retry policy? These retry policies is because it helps. It's not required, but it helps that in your let's do up here. In your retry policy, come on. So in your retry policy, in your catch block, and I'll point this. I'll see if I can find it for you because I've got a blog post. And again, it's out on MSDN. But there are ways to say if there's an error and it hits my catch block, if you're throttled, you will get an error code back. Okay. There are ways to determine and to interrogate that error code to figure out why you were throttled, why you were throttled and what you can do about it. Okay? And I'll actually show you, I forgot to put an example together and I apologize, but I'll actually show you a blog post about it and you can go read about it. And it's actually out on MSDN. And the reason I think I didn't do that is because there was, we kind of redid the codes that are coming back, right? So there's actually new codes you'll get back. But the same concept and principles apply. If you were throttled, you will get an error code back. At the end of the, at the end of the error message, hey, there was an error, blah, 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 blah. It'll say code, and here's the number. You can actually take that error code and interrogate that error code to figure out why you were throttled. Right? And based on that information, you can determine what you need to do to ensure that you're not throttled more and to scale back. Right? So that, as a developer, that's kind of important. Okay? Okay. So, all right, let's keep going. Mike, how much time? What time is it and how much time do I got?
It's almost 7:30.
How much time do I have?
Till 9.
Woo! No. We'll go as long as we need to.
But according to the audience,
Going to the audience, we're done! Thank you for coming. Yeah, thank you. Yeah, clapping. Get him out of here! Get him out of here! That's right. His jokes are lame.
if you see a big walking cane,
That's right.
you know that's your excuse.
I went to a thing I did another presentation one day, and they said, we want to know what SQL Azure is. So I said, I put up once, I had the intro slide, and I wrote another slide that said, SQL Azure is awesome. Thank you for coming. I got a round of applause. I said, all right, I'm out of here. He didn't like that. Okay, so how much, from a developer perspective, do you guys care about, I know you guys, at what level, I'm trying to figure out the best way to ask this question. As a developer, what level, how much do you care about database application performance? Do you care what happens in the database to get that, to make sure your queries returned okay? Do you care?
Yes, because our manager will say that it's our fault that it doesn't work. So. Okay, this is kind of a two-part question. It's kind of a, I don't want that to be a lame question. It's just, so a lot of developers just like, as long as my query comes back, I don't help you fast, I don't care, right? He probably works for himself.
Okay, all right. Well, Maybe. All right. So the reason I ask is because we can talk about database scalability. And here's I do have a sample around this because the reason I ask is because there's the sample I have. It just shows the power of database scalability through SQL Federation, right, from the database side. Okay. So as developers, we know application scalability, right? We create this new application, this great application that sells the greatest thing since sliced bread. We open the doors, users start coming in. We find out that, oh crap, we've got to start scaling the application, so we throw up multiple, additional instances of the application. This is a website, for example. So, more front tier instances and then more middle tier instances, right? But unless our application or unless our database can keep up, doesn't matter how many middle tiers and application layer instances we throw up, right? We want our database to keep up with everything else, right? So how do we do that, right? Wouldn't it be nice if we could apply that same concept that we apply to our application to the database? Just let me have more instances of my database, right? Yes, that'd be nice, and actually we can do that, right? And the great thing is, for you, it means no changes to your application. Yeah, that's awesome. Woo! Yeah. Is he done yet? All right. So we want that same application, we want that same concept really applied to, let's scale more instances of the application. And this is what really SQL Federation does. Are my jokes that bad? All right. So basically you want to say, I want to be able to go from one node to hundreds of nodes and back if I need to by scaling out my database. Okay? And so let's jump out and see how that's done. Okay? And the great thing is that you're, as an application developer, you don't care. Or, to care less. All right, so let's do this. So what I'm going to do is I've got a new all right. Where's our Federation demo? Okay. So I am a top skilled UI designer. There's my award-winning. That is my award-winning application. All right? Yeah.
The same as mine.
Yeah. Same as mine. All right, a button and a list box. Woo! Yeah. You know how long that took me? I'm kidding. All right. And what I'm going to do, this should still work because I connected earlier. So, what I'm going to do is I'm going to connect to this server. Come on. Yeah. Okay. So what I'm going to do is I'm going to create a database on this server. I'm going to call it Contoso.
Surprise.
Yeah. What, have you seen this before? All right, Contoso. There we go. Come on. So let's refresh our list of databases.
We just bought out Fabrica.
They did. They just bought out Fabricam. Actually, they merged. It's Fabritoso. Yeah, that was lame. I know. Yeah. We're here all night. Try the veal. Okay. DB. So what I'm going to do is, so I'm going to create, and what this is doing is this script. I'm just going to run it. Okay. All right. So what this is doing is, I'm not going to get into it unless you want to. Just raise your hand. But what this is doing is it's basically, I'm in the Contoso database. This screen is bigger than the. It's basically it's creating some tables and some objects, and then down here it's creating a federation. Now, unless you want me to, I won't get into the guts of SQL Federation. Basically, a SQL Federation is the ability. It's just like a federation. It says create federation, expense federation. A federation is much like any other database object: table, view, store procedure, right? The difference is that a table, a view, and store procedure, the boundaries of that object exist within the bounds. Its boundaries are not limited to the database. And the reason for that is because as we start partitioning our data, right, we just basically are creating more databases. So it needs to be aware of all, it needs to know and be aware of all the other databases that are being created as we scale. So its boundaries are really sort of server-wide, not just database-wide. And this is really, I guess, from an application standpoint, I don't know how deep you want to go. You can go as deep as you want. But what I'm doing is I'm creating a federation, and I'm using that federation, then I'm creating some objects in the federation. My syntax changes just a little bit, but it's the same thing. I'm still creating, let's go back up here so you can see my statements here. Right, so create federation. The column I want to partition on, data type, it's a range partition, meaning low to high, right? And then I'm going to use that federation, and then here's some objects that I'm going to create, right? Create table. And you can notice that they're a little different because I'm saying, hey, I want to federate on this column. So I'm still doing a primary key, right? Things like that, but they changed just a little bit, okay? I'm going to, so if there's questions you have on there, I'm going to keep going, but if there's questions you have, please just holler, okay? So I'm creating a few more, let's see. Let me execute that, and then I'll explain what's going on. Right, so it's doing a few more tables. So it's I've got some related tables. So it's user expense report detail, one to many, right? So I'm doing that, and then I'm just creating some foreign key, primary key relationships, and then inserting some data. Okay. The reason that you might be concerned about this is other than the little syntax change as far as primary key federated on whatever, right, syntax, what stands out in that create table statement? What's that? Federated on, right? Yeah, besides that, right? Federated on means here's a column I'm going to federate on, right? That I'm going to partition on. But other than that, other than the primary key, other than the federated on, what stands out? Should be blatant. What stands out in that create table statement?
The comments.
The comment. Which one? The
identity.
Identity. Right? Why did we comment that out?
You probably don't want the same identity to be generated on it.
So, right. Identities are not supported in Windows Azure SQL Database, they are not supported in SQL Federation. Yeah. Okay? Why? What were you saying? Expound on that. Huh?
Because there's probably multiple databases and multiple servers involved, and they might generate the same duplicate.
Thank you very much. Right? Not multiple servers involved, but at least multiple databases. So every time I partition my data, a new database is being created. Right? So in a simple scenario, we're not going to be too worried about the same IDs being generated. But if we're in a complex, multiple tables, think AdventureWorks database, hundreds of tables, and we're partitioning on those. Right, somewhere down the line, in the bowels of all the relationships in the tables, it's possible that duplicate IDs could be generated. Right now, that's okay as long as we don't try to merge. Because what happens if we try to merge? Crap hits the fan, as they say. Right. So now all of a sudden we got, hey, I got an ID 400 here, I have an ID 400 here. Who wins, right? So in that case, so in that scenario, that's why right now, and we're talking about that because there might be the possibility that we say, hey, as we split, let's do some SQL reseeding of identities and things like that. That's not there yet. All right, so this is done and executed successfully. So now I have this database, and what's really awesome is that the database knows that if it's federated, we have this new node here called Federations in SQL Server 2012. Right? That's awesome. I love that. Okay, so I'm going to run this app. Right? And the script created a federation and inserted some data, so I'm going to run this. Okay, and I get user ID, I get Sherry. right? She's user ID 71. So let's take a look at the code behind this really fast. Let's take a look at the code behind this wonderful, awesome, award-winning application.
You are going to show us how we do identity, right?
Sorry, how to do identity?
Yeah.
We'll get to that.
Okay.
There's no way to do identity, so you're responsible for managing your own IDs. That's how you do identity right now. Right. So we will talk about that. So don't panic. Okay. Okay. Whoa, the screen. Okay. So in normal, we need to probably take a look at those tables again in a little more detail. But in normal fashion, what this is saying is, notice my select statement. Right. Typically, when we query, we say select, in this case, select first name, last name from user where user ID equals 71, right? That's a typical SQL statement, right? A simple one, but they're typical, right? However, in this case, think of federations like a hotel, right? In a hotel, you've got your room number. You walk into the lobby, you go into the elevator. Let's say you're in room 1410, right? So you come in with your room number 1410. You hand that to the, let's say you hand that into the, walk into the elevator reads your card and says, oh, you're in 1410, so it takes you to the 14th floor, and then says, all right, your room's down here, okay? So for some reason, you walk into the elevator the next day, the maid says, hey, we found termites in your room or whatever. We found something wrong with your room. We had to move you up to the 16th floor, right? So you walk into the elevator and says, oh, you're now on the 16th floor in room 14 or whatever, right? Federations behave the same way, right? Because at any given time, the database knows where the user that you're looking for. So just like, the question I asked about, has anybody built retry policies? Has anybody tried to build data caching in their application? Yeah. That was probably a lot more painful than retry policy, right? Yeah, come on. Yeah, it was pretty painful. Because at any given time, your data could be out of sync with your database, right? And you have to go recache that, and how do you recache that, things like that, right? Let the database do that. So what happens is you come in with user ID 71, you walk in, user ID 71, and Azure says, oh, user ID 71 is over here in this database. Right? Tomorrow you come back and say, oh, you know what, user ID 71 is over in this database. So you don't have to worry about where the user ID 71 is. You don't have to cache anything in your application. So for an application, as a developer, you don't care. You don't have to make any application changes at all, right? So in this example, what we did is we created a database with about 100 users, okay? So the way to demonstrate this is if we look at this, I'm going to run another script against this database. Let's close this. Don't want that anymore. Let's run another script against this database, because what I'm going to do is I'm going to split. Contoso, right? So how do we work with federations? How do we split? How do we get that database scalability so your application performs better than almost than it would did on-prem, right? So what we're going to do is we're going to go down here and we're going to say, let me give you an example, right? So we're going to say use federation with reset. And notice you can almost see it. The database drop-down list over there. Can you guys almost see that? Right? Pay attention to that as I start executing some of these queries, right? So this one's not going to change it because it's still Contoso, right? Be happy.
Sorry, it's the traffic on the road.
Yeah. So you want me to talk longer? Is that what you're saying?
Yes.
Instead of 9, you're going to give until 11.
We can stay here all night.
All night long. Yeah. Oh, man.
There are strobe lights and everything. So.
All right. For my next act. All right. So here's some of the DMVs really quick that we can look at to say, hey, what's going on with our database, right? So these are some of the data management views. We won't spend a lot of time on those, right? But let's go back. Let's query the user table and the expense report table. Oh, that error. Why did that error? Yeah, I expected it to error. It's not a surprise. But why did that error? Because these tables were not created in our federation. When I said create federation, it actually created a new member database. And those tables were created in that database, right? So what I need to do is I need to go over here and say, let's go into that federation member. So basically, let's go into the lobby and tell it which user we want. So it takes us to that specific database, right? Then we can go and query these. Bam. Okay. However, we have one federation member that's got all our users in it. So what I'm going to do here is let's split this thing. So we got to go back to the root to do that. The root is our just original Contoso database. And let's split that. What I'm saying here is I did use an int as the key, so it's 1 to 100, right? I want to split it 40, right? So let's split it 40. Okay, this is going to go back and say, yep, it's done, but really what it did is it kind of kicked off a job. So the way to tell is we can actually go back here. Let's go back to our root. Anytime we need to see what's going on with our federations, we need to go back to the root. There we go. Oh, that's done already. That was fast. So now notice that we've got down here, where am I at? Oop. I have two ranges. I have two federation members now, right? Load to 39, or load to 40, 40 to 100. So now we have two databases, okay? So I have a root and two federation members. Each one of those federation members is a physical database, right? So as I partition, it keeps creating new databases and moving that data and spreading that data across, right? So going back to my example, what changes do I need to make to this to my code here to query user 71? What's that? 0. I don't have to make any code changes. User ID 71 is not anymore in the original database, right? It's in a completely different database. But when I run this, I should get Sherry back. There we go, right? So from a scalability standpoint, I said, let the database manage that. All I want to do is just query my data. Okay, so we said the database can manage my scalability. Let me start creating different partitions and scale out my data. And I, as an application developer, don't care. I don't have to store it. I don't have to make any. I shouldn't say any. I don't have to make a lot of changes. The changes you probably do have to make that we saw, right? Really, our queries changed somewhat. Okay, because you're not saying select first name, last name from user where, right? The where my where just got implemented into the use federation statement. Okay, so from an application standpoint, I'm not caching the data, but I do to some degree have to make changes to my data layer to say, you know what, just pass me ID, I'll call the use statement, and then I don't need to pass a where anymore, right? Now, you're asking probably, what if do I have to change my current application? We're not asking you to go use SQL Federation for database scalability and rewrite your existing database in your existing application, right? Depending on how complex it is, depending on the severity of changes you might have to make, that's up to you, right? But the key here is that the concepts that we've talked about here don't apply just to SQL Federation, but apply to database scalability in general, right? If I want to take my database and partition that database across multiple nodes, right, then you can use SQL Federation or any other database scalability mechanism or concept or principle to scale your data, right? The key concept here is that you shouldn't, from your application, have to make too many changes to your code, right? That's the concept. Okay, we didn't get too much into the kind of the depths of the syntax and all the concepts behind federation. So I wanted to focus on the application side, but this is federations. Okay, does that make sense? We good so far? Okay, I can go deeper if you'd like, so let me know. All right.
What happens if you do a join on different tables?
So you can do join. The concept here is all right, so this is a deeper discussion, but let's get into that since you asked.
No.
Yeah, no, so you can do joins. I can say the same syntax you would use today to join, you know, select, yeah, star. Let me think about that, because you're still saying use federation with an ID, but you're not doing it. You're just taking away a where clause. So say join on, join on, join on. You're just excluding the where. Does that make sense? Right? The problem is, and I don't want that to sound negative, but so let's think about. Let me give you an example. In this example, we had user, expense report detail, and those three tables had zero other relationships to any other tables, right? So that was a fairly easy example. Well, let's take, for example, you guys familiar with the AdventureWorks database? Who's familiar with the AdventureWorks database?
As a name or as a structure?
A structure.
Yeah, I
Yeah, now all the hands go down. So the AdventureWorks database.
Northwind.
Huh?
Northwind.
All the hands go up. Yeah, much easier database. So those are both staple databases. Staple meaning they've been around for eons. And let me just tell you, are we live? I hate the Northwind database. Okay.
No, that's.
Yeah. That's Bomber's like, what? No. And let me tell you why. Because just a quick tangent. The Northwind database came from Microsoft Access, which came from Microsoft Excel, sort of, right? Which means Northwind database is full of columns and table names with spaces in them, right? Huh. Now, I wouldn't mind so much as a SQL guy, that just irks me to no end, right? But I'll let it go because the reason I actually went to the office people and I said, why didn't you do this? And she goes, yeah, we know it's not best practice, but the reason they did that is so that people can easily migrate from Excel to Access. Really? Okay. The problem is, if you're not, anybody's familiar with Windows Azure mobile services, right? The problem with Windows Azure mobile services is that you cannot have table names and column names with spaces in them. Luckily. Right? So what if you want to take that database and so, I mean, that's the problem. I had to go through this exercise of migrating the Northwind database from Access to Windows Azure SQL Database, and in the process remove all the spaces. Right? And then put a mobile service on top of it. So that was just, oh my goodness. Okay. That was not fun. All right, so back to the AdventureWorks database. Otherwise, I would love the Northwind database. But the AdventureWorks database, I think, is even a better example because it has 4 or 5 groups of tables, right? Employees, products, orders, salespeople, production, right? So about 5 groups, and every group has about I think about 4 or 5 tables or more, right? I can't remember, I think, how many tables are in there total. But you've got, you know, and all these tables, if you open this in SQL Server Management Studio and do a diagram on it, all these tables are interrelated, right? So, how do we do a query? So if we're going to take, one of the examples we did is we took the AdventureWorks database and made a Windows Azure SQL Database federated version of that database, which means we had to go through there and say, all right, what group of tables are we going to partition on? Employee, employee, product, production, orders, what is it, right? Which meant if we were to do that, at some point in all those relationships, so remember in this example, what we did is we were in this simple example, we did our root database, created some tables, and then created our federation, went into that federation, which is a brand new database, and then created some more tables. That's how it works, right? And then as we split, we split the federated for the database. We don't touch the root, right? All the tables in the root stay, but as we split the federated database, this is what we keep slicing up, right? So in the AdventureWorks, let's say we partition on orders. Well, orders are an order ID, right? Orders are tied to what? Products and customers, okay? So if we wanted to just do products, that means we create all our other objects in the root database, then go to our federated member database and start creating orders. But because now they're in two different databases, what happens to our relationships? We have none, right? Because you can't do joins between two databases. So at some level, yes, so to answer your question, we could still do joins, but at some point, depending on your database, you will lose relationships. Just the way it is, okay? You will lose relationships because how do you if I take all my orders and put them in their own database, well, orders are tied to customers. Well, my customers are in this database, so at some point I'm going to lose relationships, right? And then you can't do joins between those, right? Now that's kind of a far-fetched, that's kind of almost a worst-case scenario. They may not apply to every database. So if you're going to do database scale out, you have to look at your database and say, how am I partitioning my data, and what does that mean for my tables? Okay? Now, as an application developer, you're probably going, that's not my problem, right? But maybe it is, right? So how do you do joins? Because there are companies out there where a developer is the same guy as a SQL guy, right? You're writing T-SQL. But if you're writing T-SQL and not using for procedure or whatever, right, at some point it's going to affect you. How do I, in a federated environment, how do I join two tables, right? How do I, if I've got, let's say for example, and I don't want to go too much longer on this, but how do I then say, okay, I have data spread out across 10 nodes, 10 federation members. I want to do a top 10. Well, my top 10 can be spread out amongst all these nodes. So what I have to do is it's called a member query and a summary query, right? Basically, it's called a fan-out query. Let me execute one query against all my 10 nodes. Bring that, so basically do a top 10, top 10, top 10, top 10. Bring that data back, aggregate that data, do another top 10. Okay? So as a developer, this affects you a lot, right? Depending on how are you doing it, right? Are you making these, are you calling for procedures? What are you doing, right? So this potentially could affect you a lot. Not to say it will, it might, right? You're still writing queries the same way, you know, select, inner join, cross join, left outer join, all that great stuff. You're just not you're just not saying where. But then your joins, the reason I bring this up is because your joins, you may have to exclude one table and maybe execute a query here, bring that data back, aggregate it, and then execute another query. That's why I bring this up. Does that make sense? Okay. So it makes it a little more challenging, but you get better. Depending, you get better performance. Depending, right? That's why I covered that. Okay. All right. Windows Azure tables. Then we'll do this and we'll call it a day. Now, okay. Who's familiar with them? Who's developed against Windows Azure tables? A few of you? Okay. You know that there's been some changes from 1.7 to 2.0?
Yes.
You guys know that? One guy painfully became very aware there was some changes. Is that true? Who uses the old 1.7 and earlier? Anybody use 2.0 yet? Two of you? Okay. How'd that go? Who wants to go first?
After 2 days, it went quite okay.
After 2 days. The first 2 days were
migrating code.
I understand the reason why they did it, but they could have done it in a more transient.
Well, okay, so let me bring this. I showed this at the TTT today. Camps data. Showed this at the, oh, wait a minute. Look at that. Okay. Okay. So for those that are using Windows Azure Tables, they released the 2.0 client library, what, just a few months ago, not long ago. Okay. I'm actually going to open that blog post because it explains, because that way I'm not talking to death, and I can show you where, if you want to do more information, you can get some of this stuff. However, I do want to point out the bottom 2 points, right? Good things, better performance, great new features, extended platform. The bad news, if you're using 1.7 and earlier, and then you upgraded your client to 2.0, your application broke. There were some breaking application changes, right?
Some. It didn't work.
Well, that's what I'm saying.
Changed it completely.
Not completely.
Yeah.
Not completely.
The only thing that you didn't have to change was the actual declaration.
And
of the
no,
classes.
no, you're like this guy that was in my, that I went to in,
What? We're 2 in year 1.
By Microsoft, I'm right. No, I'm kidding.
And we have that update.
Yeah. That was live too, by the way. There was this guy that, I went to this guy's session at Tech Days here, and he got to Windows Azure Tables and goes, and this guy writes an app. It was amazing. He writes this app for, he's a Microsoft partner, writes this app, and he basically goes, Tables is absolutely worthless. What? Really? No. But anyway, all right. Let's see. Okay. So let me jump out. It's not that bad.
I didn't say it's bad. I just say that it broke completely.
I'm not saying it's bad. I'm just saying it's completely broken. All right. So,
No, but seriously, the only thing that you didn't have to change.
yeah, no, seriously, it's bad.
The only thing you didn't have to change was the connections thing and the actual declaration of your classes. The rest had to be.
Actually, no. It's well, okay. We'll talk about that. Okay.
There's nothing wrong with that, but maybe
Okay.
they
Yes,
should have-
there is. That has changed a lot.
No, I mean, but they could have done it differently.
I had to throw everything away and start completely over. No. Okay. So, can you see that? Holy cow.
Except my classes and the connections thing.
So we made some distinct breaks with storage client 1.7 and prior in order to support common paradigms across .NET and Windows runtime applications, right? So in essence, what I want to show you here is that down here it says what's new. So there's a whole slew of what's new, right? Better support, 150 new tests published to GitHub, support for custom use headers, a whole slew of new stuff, better performance, better integration and functionality, things like that. However, new dependencies, things like that. But if you scroll down on this, there is a list of breaking changes per client object. So in general, blobs, tables, queues. But it's really not that bad. Right?
Like the top 90%.
Right? So where's tables? Right? So tables, only a few changes to tables.
Few changes too.
Yeah, right? So I don't know what you're, anyway. It's really not that bad. It's really not that bad. Okay, so, and the reason I bring this up is because who's created a Azure Storage account? Who has an Azure Storage account here? Okay. Who has created your Azure Storage account prior to, I think, October?
17.
Huh? 17th of July. Who knows the exact date and time? I created it. Right, okay. If you want to take advantages of these new features, performance and things like that, and use the 2.0 client library, you have to go and the 2.0 client library will only, how do I say this the right way? The 2.0 client library will only take advantages of these new features, performance and things like that, for storage accounts that were created later than, let's say, October.
17th of July. No, actually, it's 17th of July.
Is it 17th of July? I think it's later than that.
No, it is 17th of July. It's like
It's later than that.
Okay.
Get on.
So, okay, let's meet somewhere in the middle. Actually, we'll find that. Actually, because the 2.0 client library isn't that old.
No, but
but the actual changes were sent to July.
We'll have to look. Anyway, it actually might be. We'll look. But anyway, if you want to take advantages of these things, you have to have created your account later than somewhere between 17th of July and October, right? Which means that if you have created your account earlier than that, you cannot use. You can still use the 2.0 client library, but you cannot take advantage of these features, right? So what you have to do is go create a new account and migrate your stuff over to that new account. Okay, that's not hard. It's just that's a little time consuming depending on how much stuff you have. Okay, so 2.0 client library. It's actually really good. I've got a sample app. I don't know if I want to bore you to death with that. It's the great thing is they saw us in the TTT. Really working with what used to take like 4 or 5 lines of code to iterate and get my tables is like 2 lines or 3 lines of code now. It's much streamlined. Much more streamlined, much easier, more efficient to work with Azure Storage. Okay, plus you get better performance. But again, if you want the performance and all the additional benefits, go create a new account, migrate your stuff over to that new account, and then download the 2.0 client library. Okay, let's look at that one. Okay. I don't need that. So let me keep going on this one because the points I want to point out from here, not architecture. Let me just do this. For those, for those that are familiar with or not familiar with Azure Storage, the thing we run into a lot is the architecture. I don't want to get into the architecture. That's but the concepts. One account can have multiple tables. One table, multiple entities. Entities can be of any schema, right? So we do not do any schema or type checking, right? Because it's just key value pair. The thing I want to point out here is, oh, did I go too far? I went too far. This, right? And you guys probably already know this, but for those that don't, I want to say it anyway. There is a huge difference between a Windows Azure SQL Database and Azure Tables. One is relational, primary keys, foreign keys, indexes, tables, all things like that. Azure Tables is not relational, right? Do not take your relational database and move it into Windows Azure Tables. It is not meant for that. You could do that, but you lose. You cannot do, there's no joins, you can't join between tables, there's no primary key, foreign key, there's the concept of an index, but there's only one. You can't create additional indexes on these tables. You can do queries, inserts, updates, deletes, right? But it is not relational, and do not use it as relational, right? It is, for example, if I were to create a Twitter type of application, I would put this on Azure Tables all day long because it's key value pair, high transactional, right? I would not put Twitter on a relational database, right? You probably could, right? But you'd have to scale out pretty good. But the number of transactions, their number of transactions they're counting for Azure Tables is like 20,000 transactions a second. That's a lot, right? You won't get those against a Windows Azure SQL Database unless you scale out quite a ways, right? This is not relational, okay? It's not meant for that. You can still do CRUD operations, but it is not meant for joins and things like that. Okay, so no fixed schema. We don't do any schema or type checking, so I can have different data types. I can have one column with I can have one table or one row with 3 columns and another row with 10 columns if I want, right? What I want to get to here is querying. Okay, querying matters a lot from an application standpoint, right? You've got to know when you define a table, the table will have a partition key and a row key. The partition key drives how the data is automatically partitioned and how the data in the table scale, right? This is important when you're writing code against these tables. Okay, so the purpose of the partition key and the row key is to determine how you query this data and how the data partitions. You can have the same partition key. Let's say, for example, movies. You've got a comedy partition key. You've got a drama partition key. You've got adult contemporary partition key. Each one of those must have an associated row key, but the row key must be unique per partition key. For example, do not use your identity column out of your database for a partition key, because then every row is its own partition, and scalability is just like whatever, right? But you want to use your identity column for the row key, for example, right? Which is fine, right? So it's used, and that's actually old because now we're talking about at least 20,000 transactions per second for Windows Azure tables. Okay. Anything on that? So really, in essence, tables are partitions to support the load balance across multiple tables, right? So when a particular partition gets hot, Windows Azure will automatically partition that data out using partitions. So, for example, it has partitions and partition ranges. I don't know if you guys can see that. Let's do this. Right? Not that. Here we go. That's better. All right. So, for example, our partition key, which is a category in this case, so we've got a bytes partition key, a canoes partition key, rafts keys, whatever. And as partitions start getting hot, meaning they start getting a lot of transactions against them, Windows Azure will automatically take the hot partitions and say, you know what, we need to move those out. And the great thing is this is free to Windows Azure. Free meaning you don't have to code anything to do that partitioning. Windows Azure will do it automatically. Okay? But what's up to you to determine what your partition key and row key is. Okay. Lastly, let me talk about pricing. Just really quick. A few slides about pricing and things like that. Okay. You guys go. Can you guys see that? So let's just do this. It's ridiculous. There. Whoa. All right. So from a pricing perspective, database is just a flat cost across databases. The concept here is that there are no transaction charges against your database. Right, so you can insert, update, delete all day long, no transaction charges, right? The reason I say that is because from an application standpoint, if you've got a chatty application, we don't care, right? However, if your application is on-prem, any data that leaves the data center, data into the data center is free all day long. You could take terabytes and terabytes and terabytes of data into the data center. That is free all day long. The minute data leaves the data center, you're charged. So if you have a very chatty application, right, and data is leaving the data center, like let's say you put your database in the cloud, your on-prem application's on-prem, any data that leaves the data center is charged. So if you have a chatty application, you're incurring charges, right? So you got it from an application perspective, you need to be aware of that. How much you're getting charged for application egress. Right? But more importantly, which one is it? Okay. While Windows Azure SQL Database does not have transactions, Azure Storage does. Azure Storage does have transactions, right? Tables, blobs, every 100,000 transactions. That's very, very cheap. However, that stuff could start adding up very quickly. So, batch. For example, if you're one insert into a table, one transaction. One read from a table, one transaction. One delete from a table, one transaction. Right? One placing a message on a queue, one transaction. One reading a message off a queue, one transaction. Right? So the concept here is that you want to wrap things in batches, right? So for example, table save changes without. So in other words, when you're saving, do things like save changes options dot batch. Because that'll say, it doesn't matter how many you're doing, if you're doing like 100 at a time, that's one transaction, right? Not 100, because you save things as a batch, right? So what you want to do is if you don't, even if you're sending 1,000 at a time, right? If you don't call save options batch, that's a number, that's more, that's a bunch of transactions. But if you call save options batch, then that's transaction, right? Because of the limitation of .NET and REST, you can only do 100 at a time. So if you've got 1,000 transactions and you send those in a batch, that's 10 transactions. But it's 10, not 1,000, right? So batch your transactions, okay? All right. What else? Okay. All right. That all? Okay. So that's all I have. Right? Is there anything else you guys want to know? Anything? Bueller? Bueller? All right. Again, what do you guys want? Is there any questions? Anything you guys want to know? Anything about what we talked about? Anything that we didn't talk about? Anything regarding whatever? Anything you guys want to know? This is what? It's about 8:30.
It's 8:15.
8:15. How long do we go?
9:40.
Okay, almost done. All right. Anything else? Anything you guys want to know? Anything? Gardening?
Yeah.
I am not the guy to ask for gardening.
The right date.
What's that?
I found the right date.
And?
It was 7th of June.
Oh, we were both wrong.
Yeah.
I thought it was later than
It
that.
was with the spring release.
It was with the spring release that they changed everything on software, hardware, and all those things. And after that, all the accounts that are created at that time, they get all the benefits that they were released.
Yeah, okay, but the client probably didn't come out till the.
No, it wasn't then, right? The client came way after.
Yeah, okay. All right. Okay, well, anyway, if you have any questions, I'll be around. Otherwise, thank you very much. Appreciate you listening. Thank you.